In lesson 13.4, you will evaluate inverse trigonometric functions. In our first problem, we're going to evaluate the expression in both radians and degrees. So here we have an inverse trigonometric function, and the inverse tangent of 1 is equal to theta says the same thing as the tangent of theta is equal to 1. So these two equations are inverses of one another. In one equation, the output is theta, and in the second equation here, the input is theta. They're inverses of one another. But in this form, in this second form, we know that theta must be in the first quadrant. The terminal side of theta is in the first quadrant for the ratio to be positive. Because for a tangent inverse function, it's only defined for the first quadrant and the fourth quadrant. So because that ratio is positive, our theta, the terminal side of theta, lies in the first quadrant. So I'll build my right triangle with the x-axis, and I'll use the definition of tangent to label the sides of that triangle. Okay. 1 is equal to 1 over 1, and the definition of tangent is opposite over adjacent, so the opposite side of theta is 1 and the adjacent side is 1. Well, then you recognize that this is a special triangle, 1, 1, the square root of 2, and you realize that theta then must be a 45-degree angle. So theta is equal to 45 degrees, or pi over 4 radians. Okay, in our second problem, we have the inverse cosine of negative 1/2 equals theta, which again says the same thing as the cosine of theta equals negative 1/2. Now, because the ratio is negative for cosine, our theta, the terminal side of theta, is in the second quadrant, because the inverse cosine function is defined for the first quadrant and the second quadrant. The ratio is positive in the first quadrant and negative in the second quadrant. Okay, so here's our angle theta that we're talking about. Okay, we build our right triangle in the second quadrant, right triangle with the x-axis. This is the reference angle for theta. We apply the definition of cosine, which is adjacent over hypotenuse, negative 1 over 2, and we recognize that we have a special right triangle, 1, 2, the square root of 3, which means our reference angle is a 60-degree angle across from that leg of length square root of 3. We have a 30-60-degree triangle. Okay, so since our reference angle is 60 degrees, that means theta is 180 degrees minus that 60, or a 120-degree angle. And now 120 degrees is equivalent to 2/3 pi radians. So theta is equal to 120 degrees, or 2/3 pi radians. Okay, in our third problem, we're working with the inverse sine function, and this again is equivalent to the sine of theta is equal to the square root of 2 over 2. Now that's been rationalized, so I'm going to write it without that fraction being rationalized. I'm going to write it as 1 over the square root of 2, which is equivalent to the square root of 2 over 2, so that when I label my triangle, and because that ratio is positive, the terminal side of theta is going to be in the first quadrant. Again, if the ratio were negative for sine, we would be building our triangle in the fourth quadrant. Okay, so I'm going to drop a perpendicular. This is theta that we're looking for. I'll apply the definition of sine, which is opposite over hypotenuse. So opposite over hypotenuse, 1 over the square root of 2. And this shows me that I have a special triangle again. Sides are in the ratio 1, 1, the square root of 2. So I have another 45-degree angle. Theta is equal to 45 degrees. And that's equivalent to pi over 4 radians. Okay, one last problem on this page. Inverse cosine of 3 is equal to theta, or the cosine of theta is equal to 3. Now if we try to build our triangle, and again it'll be in the first quadrant because the ratio is positive. For sine, cosine, and tangent, if the ratio is positive, theta is going to be found in the first quadrant. The terminal side of theta is in the first quadrant. So applying the definition of cosine, which is adjacent over hypotenuse, we've got 3 over 1. Well, as soon as I see this triangle, I know that the hypotenuse can't be shorter than a leg, so there's no solution to this problem. This inverse function is undefined. That ratio for both sine and cosine has to be between -1 and 1. And 3 is greater than 1. So this inverse function is undefined. Okay, in this problem, we want to find the measure of angle theta in this right triangle. So again, we have the opposite side labeled, and we have the hypotenuse labeled. Opposite over hypotenuse, that's our sine function. So the sine of theta is going to equal opposite over hypotenuse, or 7 over 12. Now what we want to solve for theta, this is not a special triangle. Those sides are not in a special ratio. So to solve for theta, we have to use an inverse function. Theta is equal to the inverse sine of this ratio, 7/12. And again, because it's not a special triangle, we're going to use our calculator. And I'm in degree mode, so I'm going to get a degree measure for this angle theta. I'm going to put in inverse sine, and you'll find that your inverse sine function is above the sine key. Inverse sine of 7 divided by 12 is going to give me a 35.7 degree angle. And usually we round these angles to 1 decimal place. So theta is approximately 35.7 degrees. Okay, here we're going to solve an equation for theta, only theta's terminal side is in the third quadrant, between 180 degrees and 270 degrees. So we're talking about theta whose terminal side is in the third quadrant. Okay, but we know that if we solve for theta in our equation here, theta is equal to the inverse cosine of this -2/3. And if the cosine ratio is negative, we're going to get theta whose terminal side is in the second quadrant. So what we need to find is this reference angle, theta prime, so that we can apply it to the triangle that we get in the third quadrant. So, applying the definition of cosine to this triangle, cosine is adjacent over hypotenuse, -2 over 3. So I see that this is not a special triangle, so I'm going to have to use my calculator to approximate theta. So using the calculator and working in degree mode, I've got inverse cosine of -2 divided by 3, and I get a 131.8 degree angle. 131.8 degree angle. So now, since that reference angle is between 180 and that 131.8 degree angle, I'm going to subtract to find theta prime. So I'm going to get 48.2 degrees for a reference angle, theta prime. Okay, so that means over here where I'm solving for theta in the whose terminal side is in the third quadrant, I'm going to have to take 180 degrees and I'm going to have to add on that theta prime that I just found, that 48.2 degree angle, and get a total distance then for theta of 228.2 degrees. So the theta that we're solving for, whose terminal side is in the third quadrant, is going to be approximately 228.2 degrees. Okay, let's try that again with the tangent function. Tangent of theta is equal to -5, and we want the terminal side between 90 and 180 degrees, so the terminal side is going to be in the second quadrant. Here's the theta that we're looking for. We need to know again this reference angle, theta prime. So we'll solve our equation for theta using an inverse function, inverse tangent of -5, or -5/1. And on the coordinate plane, inverse function for tangent is defined for the first and the fourth quadrant, and when it's negative, our terminal side is in the fourth quadrant. So this is our theta. And applying the definition of tangent, which is opposite over adjacent, I get -5/1, those labels, and I recognize it's not a special triangle. So again, we're going to use our calculator and we're going to approximate theta in the calculator. So putting in inverse tangent of this -5, I find out that my reference angle, or theta, is equal to -78.7 degrees. Okay, and that's my reference angle as well. Theta prime is going to be approximately 78.7 degrees. Okay, and now if I'm looking for theta in the whose terminal side is in the second quadrant, now I have to subtract that reference angle from 180 degrees. So subtracting, I'm going to get 3,101. So I'm going to get a 101.3 degree angle. Include with your notes of this video guided practice problems 3 through 6 and 13 on pages 876 and 877 of your textbook.